Right, in this video, what we are going to do, um, we have a quadrilateral, as you can see there. There's four sides at least, um, and we don't know what kind of shape it is. Okay, all that we know is it's a quadrilateral. It could be a number of quadrilaterals. So those are squares. That's a square. Those are rectangles. Those are a rhombus. Well, that's not 90. That's a rhombus. Um, those are parallelograms. Um, those are kites. Those are trapeziums. Okay, all of those are quadrilaterals. Okay, so the shape that we are given over here, they don't tell us what kind of quadrilateral we are dealing with. Okay, in fact, they want us to prove that what we have is a parallelogram. So they don't tell you that it is one. You need to prove that the shape, well, it's not a rectangle, it's not a square. You need to prove that it's a parallelogram. Okay. The way that you are going to prove it's a parallelogram is by one of the theorems. There's three theorems that we will look at. Um, and one of our theorems tells us that the opposite angles of a parallelogram are equal. So if I can prove that this angle and this angle are equal to each other, as well as this angle and this angle are equal to each other, if I can prove all of that, I have proven my parallelogram, right? Or I could prove that um, the side and the side are equal, and this entire side and this entire side are equal. If I can prove that, I've proved my parallelogram. Okay, there are another two proofs that we can look at. The other one is to prove that one pair of sides, okay, so that means this is a pair. So this pair of sides, to prove that they are both equal in length as well as parallel. So if I can prove that that side and this side, the side and the side, if I can prove that they are both equal to each other and they are both parallel, then I've also proven this is a parallelogram. And the third one is going to be, well, dealing with diagonals, but we don't have diagonals right now. But if we can prove that our diagonals bisect each other, so if I can prove that this one and this one is equal, and I can prove that this one and this one is equal, then I've proven a parallelogram. Okay, great. So clearly it's not going to be that last one because you don't have any diagonals. I don't think we can prove that our lengths are this length, for example, and this length. We don't have enough information to prove that those are true. So I think for this one, let's go ahead and find as many angles as we possibly can, so that if I can prove that this angle and this angle are equal, and this angle and this angle are equal, then I have enough reason to say that this is, without a doubt, this is definitely a parallelogram. Okay, so let's get into this. um, well, the given information, right? So they tell me these two lengths are the same. So if those lengths are the same, then I know the shape that I'm dealing with is an isosceles triangle. Okay, so let's talk about isosceles triangles for a second. If you have an isosceles triangle and these lengths are equal, then you will also know that these angles are equal. And that's what we have over here. We also have that same shape over there. Okay, so let's look at this first one. Because these are the sides that are equal, the lengths that are, or the angles that are equal, are opposite the lengths that are equal, meaning this one and this one is going to be equal. Okay, if I look at the other isosceles triangle, because these are the lengths that are equal, this angle and this angle will be equal to each other. Let's use two arcs there. Okay, so we don't have that information yet, but those will be equal to each other because of the isosceles triangles. Okay, let's start by saying angle B is equal to 65 as well. Okay, 65 degrees. All right, so it is an isosceles triangle, but that's not going to be the reason we write in our bracket. The reason you're going to say is you are going to say angles opposite equal sides. Right. What does that mean? That means the angles. Which angles? The angles that are opposite the equal sides. These are the equal sides. These angles are opposite the equal sides. The angles that are opposite the equal sides are equal to each other. Okay, so our reason there, angles opposite equal sides. So now we know that B is 65 degrees. Okay, let's maybe go fill it in over here. What else could we find? Well, we could find that angle F over there. Okay, we know two things about all triangles, right? One of the things we know about all triangles is that if you add the interior angles, you end up with 360, well, sorry, 180 degrees for a triangle. For quadrilateral, the sum of the interior angles would be 360. Triangle, the sum of the interior angles is 180. The second thing you know about all triangles is the exterior angle. So this one on the outside is equal to the sum of the opposite interior angles. So if you take this angle here and this angle here and you add them, it has to give you the one outside. So that's what we see over here. Here's a triangle. This one over here is an exterior angle of that triangle. So let's call that AFC. AFC is going to equal to 65 degrees. That's this one. Plus another 65 degrees. That's this one. So I'm adding these two, right? And my reason here is going to be exterior angles of a triangle. Okay, so again, the exterior angle, so this one and this one, if you add them together, it gives you the exterior angle. The exterior angle of a triangle is equal to the sum means add, the sum of the opposite interior angles. So the ones opposite this on the inside, you add those together to get the exterior angle. Great. 65 plus 65 is 130. So we know this one over here is 130 degrees. Great. Um, let's see. We still want to prove our... Right, let's go ahead and prove this one over here. Okay. So let's say that is DEC, DEC. So angle DEC, we can see that over there is a straight line. Okay. So we are going to say 180 degrees minus our 115 degrees. Okay, so our reason there is going to be angles on a straight line. Angles on a straight line. Okay, so we know angles on a straight line are supplementary, right? That means when you add them together, they give you 180. So that is going to give us 65 degrees. Okay, so let's go back to our picture. So this over here is 65 degrees, meaning this one over here is also 65 degrees. So let's write that down. So we'll say angle D, oh, angle D is equal to 65 degrees. And what was the reason for that again? It's that isosceles triangle, right? The lengths are the same. So it's going to be angles opposite equal sides. So let's write that down. Degrees, right? Angles opposite equal sides. Okay, great. So we have a ton of information, right? But we have proven now that one pair, this one and this one, we've proven that they are equal to each other. If we could prove that these are also equal to each other, we've got our parallelogram. So let's see. Can we somehow find this angle over here? And can we somehow find this angle over here? Okay, so I think the first one, let's do this one first. That's a triangle. We've got the two 65s, right? So again, we can say what that is DCE. So let's go with DCE is going to equal to 180 degrees minus, so I'm going to subtract both of these 65s because we have a triangle and those are all the interior angles. So I'm going to say minus 265s. Okay, and my reason, I'm running out of space, I'm going to put my reason over here, is going to be interior angles of a triangle. Interior angles of a triangle. Okay, so that's going to be 180 minus 65 times 2 is 130, and that is going to give me 50 degrees. Okay, so we've proven now that this one is 50. So if I add these together, that is going to give me 115 degrees. Okay, so that is nice. Let's go and see if we can find this one over here. So, right, so we want to find this angle over here, and we are going to use the fact that this is a quadrilateral. Okay, what do we know about all quadrilaterals? We know that the interior angles, or rather the sum of the interior angles, is equal to 360. So I'm going to say this angle here is going to be 360 minus this one, and this one, in order to get my missing angle over there. So let's write some of that down. We'll say that is EAF, uh, angle EAF is going to be 360 degrees minus, let's look at the other angles, 115, 115 minus, I think the other one was 65 degrees, and minus, and the other one was 130 degrees. Okay, so again, what am I saying? I'm saying that this is a quadrilateral. Okay, there's four sides, that's what's quadrilateral. So this angle will be 360 minus this one, and this one. Okay, so let's go ahead and do that. And we do need a reason. We didn't write our reason, so I'm gonna say, I'm gonna put my reason over here. This is going to be interior angles of my quadrilateral. I'm just gonna say quad, interior angles of our quadrilateral. Okay, so let's use the calculator. 360 minus 115 minus 65 minus 130, and that's 50 degrees. Okay, so back to our picture. We found out, okay, let's maybe erase this. We found out that this one is 50 degrees. So this whole angle over there is 115. Okay, so we've written a lot of things. Okay, but what has it helped us see? It helped us see that this angle here is 65. This angle over here is 65. It helped us see that this angle over here, right, which was the sum of those two, is 115. And this angle over here, which is the sum of those two, is 115. So we've proven that the opposite angles of our parallelogram are equal. Okay, so we'll say therefore, okay, so because of all of these things, we're making a conclusion. A, B, C, D is a parallelogram, right? That is a M parallelogram. How do you know it's a parallelogram? So we need to put this over here, but I'm running out of space. We'll say opposite angles are equal, right? We've proven our parallelogram. Great stuff.